Time. Any personal concept of time, for the astronaut, will almost certainly come to an end with him. Stephen Hawking. Hawking wrote about the nature of time. Our view of the nature of time has changed over the years. Until the beginning of this century, people believed in absolute time, that is, that each event could be labeled by a unique and differentiated number called time. But with the discovery that the speed of light is the same for every observer, we had to abandon the idea that there was a single and absolute time. Instead, each observer would have his own measure of time. Thus, time became a more personal concept, relative to the observer who measured it. It turned out that there is no single time pattern. Instead, each observer has his or her own time. Time remains an unexplained, just described concept for most, and for this reason it produces the most confusing interpretations. Time is nothing more than a standard measure of displacement in space. One day, it is a standard measure, demarcated by the rotation of planet Earth about its own imaginary axis, and the times of all other displacements that occur relative to the Earth's surface are parts given in relation to that standard displacement. Time is not something tangible, and it does not have its own nature different from that used by us as a measure of displacement. That is, it does not have an existence independent or separate from the notion of displacement, which is relative. No displacement exists absolutely. The distinction between time, the standard measure of displacement in space, and space itself disappears completely. The idea of displacement has only local validity, in one or two references at most, and is indistinguishable from space, since the concept of time does not exist apart from the idea of displacement in space, which is only locally valid. Also, according to Hawking, only if we could visualize the universe in terms of imaginary time would there be no singularities. Opening parenthesis ... closing parenthesis. When we return to the real time in which we live, however, we will still have the impression that there are singularities. Opening parenthesis ... closing parenthesis. This may suggest that the so-called imaginary time is actually real time, and that what we call real time is just the result of our imagination. Maybe what we call imaginary time is actually more basic, and what we call real is just an idea we invent to help us describe what we think the universe is like. A scientific theory is simply a mathematical model that we create to describe our observations. It exists only in our minds. Thus, it makes no sense to ask what is real, or imaginary time. It's simply a matter of knowing which one is the most useful description. What Hawking calls real time is the concept of time that dates back to before Newton, and which until now has remained untouched thanks to the gymnastics developed by Einstein in order to keep it that way. Time is a standard way of measuring displacements in space, which is totally dependent on the notion of displacement, and which doesn't happen for the universe, doesn't happen for the whole. Time is, therefore, just a valuable device, of enormous local utility, and it has no validity for the universe, it has no validity for the whole. Arrow of time. Many physicists often mention, and work using the idea of a direction for time. This direction would be the path in time, which seems to exist, from the past to the future. This idea that time flows from the past to the future is used in Feynman diagrams, and it's a pretty old idea. We use the sequence of events to sort out, or put in order, our memories, but the idea that time flows or passes does not correspond to the universe, does not correspond to the whole, or makes no sense to the universe at all. In a non-reductive, non-local, general or complete way, the idea of time flow is not valid. Thus, the very challenging questions at first sight, why does time pass? Or, how does time pass? Only make sense locally, because time does not exist for the universe, for the whole, due to the fact of space being continuous, which leads to perfect physical identity between movement and rest, in any situation. In a Feynman diagram, particles always move forward in time, always going from the past to the future, but they can move backward or forward in space. Absolutely nothing prevents us from putting together a Feynman diagram totally in reverse. In this diagram, the particles all go back in time, always going from the future to the past, also reversing, of course, their trajectories in space. We must then ask, what is the physical meaning of this new disposition? Does it correspond to reality? Can we say that only one of the diagrams is correct, the one in which all particles go from the past to the future, for example, or can we say that one of the diagrams is more true than the equivalent? The answer is that all equivalent diagrams, which include different paths from past to future, or from future to past, are relative, and none of them is better than the other or truer. And would they be right, or at least they wouldn't be wrong, to think that if we can go from the past to the future, why can't we also go from the future to the past? The reality, however, is more subtle, much simpler and more concise than it seems to us in our limited locality. As the validity of the two situations, past to future or future to past, is also locally limited, and as there is no displacement in relation to the universe, in relation to the whole, neither in time nor in space, so the arrow of time it doesn't exist for the universe. Time is a locally limited validity concept. It is surprising to note that, a concept that many assume serves to regulate the universe itself, has no validity at all, and serves no purpose for it. The authors deal with the origin of the universe, the Big Bang Theory, in a classic and, therefore, inadequate way. What they call universe expansion may be no more than an observed local plus in distance between galaxies, a statistical fact. When they start talking about the origin of the universe, they also want to refer to the beginning of time, but that would only be the beginning of local movements, not the universe, because because the concept of time and the concept of movement are locally limited in their validity and do not exist for the whole. There are many who think that go back to the past is possible, but the past is not kept somewhere to go, except in our memories. Repeat the past in exactly the same way, that is possible, and it happens all the time. Everything that happened in the past is now in the present, in a different way. The present is the modified past, and that is the only way, in the present form, that the past exists. If the present is the modified and continually changing past, then there are no other pasts to go. Everything that's going to happen in the future, all future events, are also now in the present, somehow. All the future will be made from the present, a future that only exists in the present. Some of the confusion they make between past, present and future comes from the only local validity of the concept of time. Time is not always a valid concept, having only a local and limited validity. For the universe, for the whole, there is no division between past, present and future. For the universe, time does not exist.